Welcome to Programming for Kids with Scratch 2. I'm Mike Lehman and thanks for joining me. This series of half-hour shows uses Scratch to introduce computer programming to kids, about 5th grade and up, and curious adults too. You'll learn all about programming in Scratch in this series. It covers loop blocks, repeat, repeat until and forever, decision blocks including if and if else, procedure blocks, variables, lists, messages, events, clones, even microphone and video webcam input. I'll create many programs including games, storytelling, drawing pictures, and programs that demonstrate important programming concepts including objects, threads, and polling. This series is all about doing and shows the creation of all working programs from start to finish. Scratch is a great first programming language and can have children very quickly creating and presenting stories and creating fun animations, all while learning valuable critical thinking skills, problem-solving skills, and the fundamentals of programming without any of the confusing and detailed syntax. Scratch presents programming commands as single blocks that are easily snapped together to make programs with very little typing. Don't let the ease of Scratch fool you into thinking that there's little here. Scratch programs can do a lot of things. Very little math is needed to make fun programs, and I give the very few equations that I'll use in a handful of about 50 challenges. Scratch is free and freely available from the highly regarded university MIT. With your web browser, you can create, share, and save your Scratch programs if you want to. You can also look online at literally millions of shared Scratch programs, and if you like, you can join the Scratch community. You can just sit back and watch this show, or you can go to scratch.mit.edu, click on the Try It Out icon, and have fun learning how to program too. All of these video challenge lessons and more are available at my ProgrammingForKids.info website and at my ProgrammingForKids.info YouTube channel. The countdown timer at the bottom of the screen shows how long until a program is first run. This show number 4 introduces variables for all sprites, introduces events and the concept of objects, shows how to upload images for backdrops, and shows a way to use the variable monitor slide bar to easily change a variable's value. I'll get started. This challenge introduces variables, events, and objects. I'll start with variables first. Variables hold values like 0, 100, -1, or they can hold a character like an X or a question mark, or they can hold a string of characters like a 4-character string MIKE for Mike, or a user's answer like the 2-character string NO for no, or the 7 characters like you win, including the space character. Variables can hold different values. Variables vary. The earlier challenge for simple ifs used Scratch system variables like size for the sprite size in the looks palette, and tempo for the note and drum beats per minute in the sounds palette. Variables can be created very easily in Scratch. For this example, I want variables to hold the values for miles and kilometers. The example will ask for miles and calculate kilometers. First, I'll create the variables miles and kilometers. I'll go to the Data palette, click on Make a Variable. In the variable name area, I'll type in miles. I'll leave the setting for all sprites as it is, and click on OK. Now I have a variable miles that all sprites can use, even though I only have one sprite right now. I'll make the other variable, kilometers, click on Make a Variable. I'll abbreviate it, KM, for all sprites. OK. Now that I have the variables, I need to ask the user for the number of miles. I'll go to Sensing and get the Ask block. I'll change the message to How many miles? Question mark. The number of miles the user enters will be in the answer variable. I'll go back to the Data palette and get the Set command. The Set command sets the variable to the given value. Right now, this would set kilometer to 0. I want to set miles to the answer the user entered. I'll use the pull-down menu and select miles, pick up answer, and drop it in. Ask will ask how many miles. When the number's entered, miles will be set to it. Next, I want to calculate kilometers from miles. I'll get another set command, attach it. Now I'll use a simple formula to calculate kilometers from miles. Kilometers are miles times 1.6, so I'll multiply miles by 1.6. Go to Operators, get the multiplication operator. I'll type in 1.6, go to the Data palette, pick up miles, and drop it in. Kilometers will be set to miles times 1.6. I'm not going to display the values with the say command since the variables are visible on the stage. The program's almost ready to run. Go to Events. Since I'm entering miles, I want to run this when the M key is pressed. Right now it's for the space character. I'll use the pull-down menu, scroll down to M. Now when the M key is pressed, Scratch will ask how many miles and wait for the answer. After I enter the answer will have the value. Put it into miles, that'll show up on the stage. Then kilometers will be set to miles times 1.6, and that'll be visible on the stage. Ready to run now. Start the program with the green flag. Now I'll press the M key. How many miles? I'll try a simple one first. 1 mile should be 1.6 kilometers. I'll enter a 1. I'll hit the Enter key. Now miles shows 1 on the stage, and kilometers shows 1.6. I'll run another simple example. I'll press the M key. How many miles? I'll enter 5. I'll click on the check mark this time. Should get 8 kilometers, and I do. This is working nicely. I can convert from miles to kilometers. I can also make something to convert from kilometers to miles. How would you do that? It'll look very much like this handler for when the M key is pressed. Give you a little more time to think about it. I'll copy the event handler, duplicate. For kilometers, I'll change the M to a K, so when the user enters a K, it'll ask how many miles. I don't want miles. I want kilometers. It'll wait. It'll set miles to answer. Now I want to set kilometers to answer. Then I want to calculate miles and change miles, right-click, kilometers. Instead of multiplying, I'll divide by 1.6. I'll right-click on the multiplication operator and change it to division. Notice how easy it was to copy this event handler and make a few changes instead of going back to all the palettes and getting everything and pulling it all together. I'm ready to try this. I should start with the green flag. Click on the green flag. I'll press the K key. How many kilometers? I'll do the first example, 1.6. Should get the answer of 1. Click on the check mark. Miles is 1. Kilometers is 1.6. I'll press the K key again. How many kilometers? I'll press 8 kilometers. It's equal to 5 miles. And 5 miles. Great. Here's an example to convert from kilometers to miles. It's also an example of using some event handlers like key press for the M key and key press for the K key. I'm finished with this example. I'll get rid of everything and start over. Get rid of the M key handler and the K key handler, and I'll get the variables off the stage. Uncheck, uncheck. For my next example, I want to keep score for an imaginary game. First I'll start by giving 10 points for clicking on the cat. I'll need a score variable. Make a variable. Call it score. Again, I'll leave it for all sprites. In future challenges, I'll work with for this sprite only, but for now I'll stay with for all sprites and click on OK. Now I have a score variable. I'll move it up to the top. When I double click on it, the monitor changes to a different presentation. Now it doesn't have the variable name score, it only shows the value. Double click on it again. I have the variable's name, its value, and a slider. It's another way to give input to the program. Click on the slider. I can drag it around and set the score. Double click on it once more, and the monitor is back to its original display. I don't want the user changing the score. They're going to have to earn the points. When I create variables like score, one of the first things I think about is how to initialize it. Initializing a variable is giving it an initial value. That way it starts with a known value. I want to set the score. I'll get the set command, go to events. When the green flag's clicked, I wanted to initialize score to 0. Next is changing score. I said whenever the sprite is clicked on, I want to add 10 points, so I'll get the when this sprite clicked event handler. Now I can't use the set command because score could be any number, and I wouldn't know what to set it to. If I were to say set it to 10, that would mean I knew score was 0. But maybe it's later in the game and it's 100, so it should be 110. I need to use a different command to change the score from its current value, whatever that is. Back to data. get the change command. Attach it. The change command adds the value to the variable. I don't want to add 1, I want to add 10. I'll click on the 1, enter 10. Now when the sprite is clicked on, it'll change the score. It'll add 10 to the current value of score. I'll try it. I'll click on the cat, and score increased to 10. Click on it again, 20, 30, 40, 50, 60, 70, 80, 90, 100. That's a pretty easy game. If I wanted to start the program again, I could click on the green flag, and it should set score to 0. I'll try it. Score has been cleared. Good. It's a new game. I can add an event to clear the score. Go to Events. I'll use when the letter C is pressed. Scroll down, C. I want to clear the score, set it to 0. I'll copy this, set score to 0. See if that works right. Click several times, 10, 20, 30. I'll press the letter C on the keyboard, and it cleared to 0. So what's the big picture here? I'll bring up a diagram. I have a sprite. It has scripts, costumes, and sounds. I have a global variable score, and I have event handlers for the cat. When the sprite is clicked on, the global variable score will be changed by 10, and clicking on the green flag or pressing the C key will clear the score. In case this is a little confusing, I'll show what happens to the variable score when the program runs. Click on the green flag, and score is set to 0. When I click on the sprite, the handler changes the score by 10. The value 0 is changed to 10. If I click on the sprite again, changes it to 20, and each time I click on it, 10 more points are added. If I press the C key, score is set to 0. If I click on the cat again, 10's added to the value, and I get 10. And again, I get 20, and again, get 30. What would happen if I created a Starfish Sprite? Since the variable score was created to be for all sprites, the starfish could change the score too. It'll need its own handlers. What if I make the starfish? What if I make the grumpy starfish take 10 points away when it gets clicked on, and if I ever click on the down arrow, it'll take 5 points away? Adding by negative numbers is subtracting. So changing by -5 takes away 5 points, and changing by -10 takes away 10 points. I'll go back to the program and create the starfish. I'll go to New Sprite, scroll down. There's the starfish. I'll double click on it. I have a starfish now. I'll move him over to the side. I want the starfish to take away 10 points when it's clicked on. I'll get when this sprite clicked. Go to Data. Change score by, click on, by -10. Then I'll go to Events. And when the down arrow is pressed, Menu, down arrow, I'll right-click and duplicate. And I'll change the score by -5. Now it's ready to run. Get some points from the cat. 10, 20, 30. Good. I'll click on the starfish. Took away 10. Score went from 30 to 20. I'll take another 10 points away. Now I'll press the down arrow key on the keyboard and the score will change from 10 to 5. One more time, it's 0. If I press the down arrow again, I'd get negative scores. In a real program, ifs would be used so the score could never be negative. But my focus in this example is variables, events, and objects. That was pretty easy. I could add another sprite. Go to New Sprite. Scroll down. How about a balloon? Double click. I've got a balloon now. Right now I'm looking at balloon and I see the balloon scripts. I click on the cat sprite and I see the cat's scripts. I click on the starfish and I have the starfish's scripts. Each sprite is its own object with its own scripts, with its own costumes. The starfish has 2 costumes, A and B. I click on A and B, A and B. The cat has costume 1 and costume 2. The balloon has 3 costumes of different colors. And for sounds, it's not surprising there's a pop sound for a balloon. Starfish has a pop sound. Be careful not to pop the starfish. And the cat has a meow sound. I'll go back to the scripts now, and I'll create the script for the balloon. Click on the balloon sprite. No script here. It'll be easy to create one. When the sprite is clicked, I want the balloon to give 20 points. Go to Data, Change, click on the 1, change it to a 20. Back to Events. I want an up arrow to give 25 points. Menu, up arrow, copy change, change it to 25. Now my program's ready. I have a score to initialize. It's good to be in the habit of starting with the green flag. I'll start with the green flag, which will clear the score. Score is cleared. That's because it's the cat that has when the green flag is clicked, the score is cleared. Each of the sprites is ready for events. If I click on the balloon, I get 20 points, 40, 60, 80, 100. If I click on the starfish, it'll take away. I'll have 90, 80, 70, 60, 50. If I click on the cat, 60, 70. If I press the down arrow key, I'll lose 5 points. 60, 55, 50. If I use the up arrow, I'll get 25 on the 50 is 75, and 100. The scoring for each of the sprites is working correctly. The scoring for the cat, the scoring for the starfish, and the scoring for the balloon. Go back to my diagram now. I have the cat and the starfish. I added a balloon, and I added the balloon's event handlers. Now I can easily see the entire program. I have the score. I'll clear it. Imagine I click the green flag, and I'm back at 0. All sprites have access to score. That was how the variable was created for all sprites. Click on the balloon. I get 20 points. Click on the cat. Get another 10, 30. Click on the starfish. 10's taken away, back to 20. Press the down arrow, then the starfish's down arrow key handler subtracts 5, leaving 15. Click on the cat again, I get 10 more points for 25. Press the up arrow key, 25 goes to 50. Click on the balloon, changes to 70. And press the C key, it sets the value to 0. I hope this diagram helps you to see that I have 3 sprite objects. Each of these objects is independent of the other. Each one is separate. Each sprite has its own scripts, costumes, and sounds. Each sprite has its own event handlers for handling when the sprite is clicked on, and each of these sprite objects have some unique handlers for handling up arrow key and down arrow key, green flag being clicked, or the letter C being pressed. I finished the 2 examples introducing variables, events, and objects. I really encourage you to work with the examples and get experience creating variables and using different event handlers. Try creating some variables and using event handlers to change their values, like counting how many times the X key is pressed. Try creating some other formulas like converting Fahrenheit to Celsius, or use a circle's radius to calculate its circumference and area. This challenge focused on events too. Events allow sprites to do things when actions happen, like clicking on the green flag or pressing the up arrow key. Sprite objects don't have to endlessly loop looking and looking for when actions happen. This challenge also talked about objects. In Scratch, sprites, and as you'll later see backdrops, are objects. They're an active and independent collection containing variables and commands. Variables, events, and objects are so important that I'll have more challenges like the last example, but I'll focus on creating shared variables for all sprites and private variables for only the sprite creating the variable. But above all, have fun with the examples. Nano Challenges are short. In this Nano Challenge, I'll show a simple way to show pictures as backdrops and cycle through them. The Scratch stage is 480 by 360 pixels. I have 4 pictures that I've already edited to 480 by 360 with a picture editing program. My files are in PNG images. First I'll delete the cat sprite. Delete. Now I'll upload a new backdrop. Napping cat 1. I'll get 3 more. number 2, number 3, and number 4. The backdrops are numbers 2, 3, 4, and 5. I can change the names also. I'll change the last one to be Cat 4. Change the third one to be Cat 3. Cat 2. And Cat 1. I'll leave the original backdrop to show how simple it is to use my backdrops even when there are other backdrops. I'll select the original backdrop 1, go to Scripts, go to Looks. I can select backdrops with Next Backdrop. Next Backdrop will cycle through the backdrops 1 through 5. I'll try it. There's the second backdrop, the first cat. The next one. Next. Next. And back to the first backdrop. I only want the napping cat backdrop, so this won't help. I'll get rid of it. I'll get switched backdrop and wait. I want a loop to cycle through the backdrops. Control. Forever. Start it when the green flag is clicked. Now to select and change the backdrop. I can use a variable to specify which backdrop. Go to Data, make a variable, call it backdrop. Okay. Move it to the bottom center. I can specify backdrops by the backdrop number 2 through 5. Go back to Scripts. Set backdrop to 2. I want to switch the backdrop to the backdrop number, backdrop. I need to change backdrop by 1 each time. After backdrop gets larger than 5, it won't work right. Control, if backdrop is greater than 5, backdrop. If backdrop is greater than 5, I want to set backdrop back to 2. Data, set backdrop, 2. When the green flag is clicked, backdrop is set to 2. Backdrop 2 is displayed. Backdrop is now 3. It's not greater than 5, so it's not changed. 3 is displayed. 4. 4 is displayed. 5. 5 is displayed. 6. Backdrop 6 is changed back to 2. 2 is displayed. I'll try the program. Stop. Green flag. It's going pretty fast. Those branches are shaking. I'll stop the program. I'll add a wait in. Go to Control. Wait. 1 second sounds a little slow. Try twice as fast. 1/2 second, 0.5. Run it. Okay. Kind of imagine the branches are moving around in the breeze. I'll stop it. Go to Backdrops. The backdrops can also be specified by the name. I've named them Cat 1 through Cat 4. The names won't change unless I change them myself, but it's very easy for the numbers to get changed by moving around backdrops and creating new ones. In some ways, using the name might be a little safer. I'll go back to Scripts. I want to use the names Cat 1 through Cat 4. I'll change 2 to 1, 2 to 1, and the 5 to a 4. Now backdrop will be a number from 1 through 4. I need to add cat in front. Operators, join. I want to join the backdrop number with the word cat. Backdrop is 5 right now. If I click on join, I'll have cat 5. There it is. I'll use that to specify the backdrop name. Now when the program runs, backdrop is 1. Cat 1 is displayed. Backdrop is 2, not changed. Cat 2. Backdrop is 3. Cat 3. Backdrop is 4. Cat 4. Backdrop is 5. 5 greater than 4. Backdrop set back to 1. Cat 1 is shown. Try it now. Stop. Run. It works nicely. I'll stop it. The same technique can be used by programs to select sprite costumes. Costumes can be selected by costume number and by the costume name. I'm finished with this challenge. I encourage you to play with the program and get comfortable with changing backdrops. Try changing the program. Try using modulus instead of the if block. But above all, have fun with the program. This is a pico challenge, and this is pico. A pico is 1/1,000,000th. That's 10 to the minus 12. 12 zeros. A pico is a very small number, so this is a very short challenge. In Scratch, a variable's value can be changed with its monitor on the stage. The monitor can have a sliding bar, and the bar can be used to change the value from 0 all the way up through 100. I'll go to Scratch and show this now. I'll get rid of the cat sprite and get the pico sprite. Delete. New sprite. Fantasy. Pico. Move pico to the center of the stage. I'll need a variable. Data. Make a variable. Call it size. OK. Move the monitor down to the middle of the stage. If I double-click on a monitor, it changes its presentation. Double-click again. The name of the variable is back, and I have the slider value. I can change the value of the variable from 0 to 100. Now I want a little program to show a simple way to use the sliding bar. Go to Control, Forever. I want the loop to continually use the size variable. I'll go to Looks, Set Size, go to Data, use the size variable. This loop will keep changing the size of the sprite to the value of the size variable. I'll initialize it. Make it 75. I want this to run when the green flag is clicked. Events, when the green flag's clicked. Now when the green flag is clicked, the size variable will be changed to 75, and the program will loop, setting the size to the current value of the size variable. Initially it'll set size to 75%, so pico will get smaller when I start the program. I'll click on the green flag. Pico's smaller, and the size variable now is the value of 75. It was correctly initialized. The program's still running. The code is highlighted. I'll take the slide bar, move it up and down, show that the value changes and has an effect on pico. I'm finished with this pico challenge. I encourage you to play with this program and get comfortable with changing a variable's value with the monitor slider. But above all, have fun with the program. I'm glad you could join me. You can review these and all of my challenges at my programmingforkids.info website and on my programmingforkids.info YouTube channel. Until next time, have fun being creative.